just to remind you guys, now obviously the slope of this function here is what? The slope of the function here is negative. And what does slope of a function tell you? It tells you what? The rate of change of that function, 11. So how quickly is the function itself changing? So if it's negative, that means it's decreasing. But what is happening to how the slope is changing? If I say, how is the slope changing, which derivative am I talking about now? Second derivative. So how is the slope changing? Is it becoming more or less negative?
More negative.
If it was becoming more negative, that should mean it's going down faster.
No.
Does that make sense? In fact, what is the derivative right here? What's the slope?
0.
0. Here it's big ass negative. Here it's 0. It better be getting less negative for that to happen, right? This is a nice, well-behaved function. Aw. Now, so what does that mean about the second derivative? In fact, look here. It's becoming less negative, meaning it's becoming more positive. Right? So if you say, like, the downturn in the economy is lessening, or something like that. You've heard these kind of things in the news. You know there's news. Some of it's real. I love the days we live in now. Alternate effects. You talk about the rate of decrease of the economy is decreasing. So what did you just say? You're talking about a second derivative. If that's happening, you're hoping that it's going to do one of these instead of one of these. Yay, we're getting better. Oh, we suck. So here it got better. So around this whole thing, the slope, is it getting more negative or more positive around this whole thing?
More positive.
More positive. So that means the second derivative is positive in this region here. Now, I've discussed this next idea several times, getting you ready for this. Isn't there a place in here? What did I used to say about some place in here? It's where the slope is most, in this case, most positive. You've heard me say that stuff before. That sounds like a maximum slope. What is this for the function? That is the max of the function. So what's true at that point? The derivative is
0.
0. If I have a maximum slope, then what's 0? A max f means f prime is 0. So a max f prime means f double prime is 0. I really want you to make sense. So if I graphed the slope, this would be a maximum. And then what's true about the slope after this point? So this would be like here. Let me see. It would go like this. Wee-haw. What's true after this point? The slope is getting more negative, less positive. So what's true on this region? F double prime of x is negative. Now watch what kicks so much ass about this. Cup up, this is positive. Cup down, this is negative. Isn't that flippin' awesome, right? So guess what we're going to do? We're going to make a sign diagram for the second derivative to see where it's cup down, where's it cup up. So let's do one, and then I'll let you guys try one. Oh, good, we got so much time. You guys are like, this can't really be a match unless you get a little something out of it. Yeah, I'm frustrated. It's a good day. All right, let's take one out of here before I try to make something up. Oh, here we go. Perfect. Yes. Okay. Let's do this one. I like it.
Oh boy, alright.
This is kind of awesome. We'll just do this one together. Not that difficult, but this is a function you guys are really not used to, which sucks. Because if you knew what the thing looked like, everything would be so much easier for you. What's G prime?
2, 3x, negative 1/3.
Right. What are the critical points for the first derivative? Yeah, be careful now. Some of you guys are going to get the right answer for the wrong reason. Is that function ever equal to 0? That function is never equal to 0. Because if you plug a 0 in for x, you don't get 0. My God. What do you get when you plug a 0 in for x? You find out that it is undefined there. Why? Because it's negative power, meaning that is on the bottom. So what's the top of this function? What's on top? A 2. What's the only way that it could equal 0 if the top was 0? Well, what do you do to make 2 0? Too bad for you. You can't. Right? One thing I like to point out when I teach courses, I have only got control on the bottom. X is where I have control. I got no control on the top, so I can't make this function 0, but I can make it undefined. Now, so it's the critical points would be x equal to 0. That's where it's undefined. Now, what do I do with those critical points? What am I going to probably try to determine for this function? What am I going to try to determine next? Before we get to the second derivative new stuff, what are we going to do like we just did a minute ago? Max and min, intervals of increase, decrease. So I got to make a sign diagram. I like it. What am I going to put on there? 0. What am I going to put on top of the 0? U. All right. So when we start graphing these things, that will be another hint to me that something weird as shit is happening at 0. What does that mean exactly? What does that mean? Where what's undefined? The slope. What is the function at 0? Negative 1. Good. So the function's fine there, but something funky happens with the slope there. All right, weird. So, if I put a 1 in, I get something that is positive. If I put a negative 1 in, I get something that is negative, because it's a cube root, right? I like it. So that means that it's decreasing from negative infinity to 0, and it's increasing from, so it's going down, resting, going up. Which means what happens at 0? It's a min. I like that it is an absolute min, you're right, because it's kind of like going up from that point both directions forever. So it's a beautiful catch, but I don't care. It's a min. That's all you need to know. But no, it's a good catch. So what's the min? We just did it, didn't we? 0, negative 1. If you try to plug 0 into this shit, you're going to be like, how do I graph that? And I'm going to say, well, put it in the right place. If you're trying to find where a function is, you have to use the function, of course. Do you see how important this is? My God, I keep saying this. Make sure you're putting the stuff in the right thing. It's supposed to go into F or F prime or F double prime. Oh, shit. And which is which? My God, be nice to yourself. Identify for yourself what's what. All right, that's semi-old news. Everything we just did. I kind of have an idea of what the function looks like. And I know something freaky happens at 0. The concavity is going to help me. I don't know if have I said that yet, that word? That cup up and cup down is called concavity. Have you guys ever heard concave and convex? So that's where it comes from, concavity. So figure out this second derivative is, real quick. What letter is that, Jeff? Bit more caffeine. All right, should be done by now. What do you guys get?
Negative 2, 6, 4, 2, minus.
I like it. You guys remember the shortcut when you take derivatives of x to the powers is just negative 1 minus 3, negative 4? I like it. When we do it backwards, we'll be adding them. When we do the antiderivative, that's coming soon, actually, to be honest. It's at the end of this chapter. Antiderivatives. All right, so now I do the same thing. What are the critical points for G double prime?
Undefined?
Yeah, it's still going to be what? 0. So 0 is exceptionally frequent. It's a critical point for the first and second and third and fourth and fifth. Right? So this is going to be x equals 0 again. Make a little sign diagram. This sign diagram is going to be, this one is just, is it going up or down? This one is, how does it look while it's doing that? Is it doing this as it's going up, or is it doing this as it's going up? Do you guys see what I'm saying? So this would be cupped down. That would be f double prime less than 0. But you can also increase like this. Those are two very different increases. If you're talking about population, you probably want this. If you're talking about profit, you want this. That's nice. Yay! Because this one might do like the, holy shit! Whereas this one seems to have some good steam to it. Anyway. So there's a whole layer of people in business sometimes talk about derivatives without realizing they're talking about derivatives, which is funny. I don't need calculus. Oh, shit. So here I do the same thing. Now when I plug in a 1 though or something, what do I get?
Negative?
Negative. That's positive and negative. And of course when I plug in a negative 1, I get
Positive.
ah. You sure about that? All right, let's double check. Do you see how there's a fourth power involved? So when you plug in negative 1 to the negative 4/3, that's positive 1. You guys don't believe me at all. I love it. So let's try negative 1 to the negative 4/3. What's the cube root of negative 1? Negative 1. And what do you get when you raise negative 1 to the 4th power?
It's positive.
1. So it's 1 over 1, which is 1. It's positive. Times a negative.
So negative.
That's why you got to slow down. Why was this one changing signs? Because it had a first power. It's not going to change its sign. It says a 4th power. Aw. So be careful. Slow down. Actually do it. Don't just go, well, yeah, it's going to be the other thing. Because then your graph is going to look completely freaky. And by the way, we are getting to the point where you're going to do all this work and then you're going to graph it showing all the stuff you found. I would much rather translate that to, you will get more points if your graph is wrong as shit, but it matches with what you found through calculus. Because I love it when all this shit is wrong and then the graph is like beautiful, especially when the graph is like this, like it's missing shit, like you didn't make your window big enough, cheater. Right. Look at that shit. So this is all about doing it by hand. You can check it on the calculator. I love that. That's awesome. But don't copy it. If you can't tell, if you had a plus here, your concavity is going to be different. Graph it that way. Because what am I testing? What do you understand what this means? Not, can you plug buttons in on this? That's not what I'm testing. Okay, sorry. See, Jeff. So what does this mean?
It just keeps going down.
No. All this means by itself is that it is has nothing to do with increasing, decreasing. Nothing.
Oh, wait, yes. It goes down.
This doesn't mean anything with the slope. Is it cup up or cup down?
Down.
Cup down. So meaning it looks like that. What about on this side?
Down.
Cup down. I like it. So it just doesn't change concavity. Do you see how over here a critical point could be the location of a local max or a min? For the second derivative, if the concavity changes, we call that an inflection point. There are no inflection points because the concavity didn't change. So where concavity changes, see how I drew that? Cup down, and then put cup up next to it. This would be an inflection point. You see how that's the location of the biggest positive slope on this, right? And what did we say earlier about the location of the biggest positive slope? It should be with the second derivative is 0. So here it doesn't have an inflection point. Okay. So what would this thing look like? So it's got to be, now watch. It's got to be decreasing from negative infinity to 0, and it's got to be cut down, right? So and what's the value at 0? What's the y-intercept? -1. Where did you plug 0 in, of course, into the function, because I want a point now, right? 0, -1. This is where everything's happening. It's 0, -1. What are the x-intercepts for this? How would you find that? How do you always find the x-intercepts? What do you do? Yeah, set the whole thing equal to 0. So x to the 2/3 equals, yeah, -1 equals 0. So x to the 2/3 equals 1. Anybody see the two answers to that? It's got a square. Do you see that? Well, let's cube both sides. I get x squared is 1. You have to make so much out of those fractional exponents. We'll kill part of it. The bottom's a 5. Raise both sides to the 5th power. Kill that shit. Now it's not a fraction. X squared equals 1. What's the answers? Plus or minus 1. So at -1, +1, it's got x-intercepts. Can you see how this thing is going to come in? It's got to be cupped down. So I'm not going to do like, I'm going to do like this. And that looks like it was naturally. And then what is it doing? It is decreasing. So it's going to come. Whoop. And what's happening after that? It's supposed to still be cupped down, but now it's supposed to be increasing. So it has to do this. That is a cusp. How did I know it's going to be something funky like a cusp? Because the freaking derivative is undefined at 0. So if you put that in your calculator, you should get basically this. Exactly. Woo. All right. So let's at least do one side of this little handout. Here it is. So obviously there's two sides to it. I'm asking you everything we just did. You're going to do on this sheet for this other function here. I like it. We're going to start with a nice function. This first function gives the charity and stuff. It's a nice little function.